Virtual storage area networks allow us to partition our data center using hardware-based partitioning and also separate fabric services between different devices. In this particular nugget, let's troubleshoot VSANs in the modern data center. So remember, the virtual storage area network is really doing two primary things for us in our data center. Number one, it is providing hardware-based separation of traffic between our devices. So this device, we don't want communicating with that device. They are in a blue and a red VSAN respectively, and we can hardware isolate them from each other. But the other thing that's important to keep in mind is we're able to provide independent fabric services for each of the virtual storage area networks. We have fiber channel fabric services specifically maintaining a separate database for each of our newly created VSANs. These services would include things like zone servers, name servers, management servers, and principal switch selection. Each service runs independently on each virtual storage area network and is going to be independently managed and configured. Now, here we can see that traffic is going to be tagged on our particular FX port, for example, and then it's carried across an enhanced interswitch link between either our MDS devices or our Nexus devices. Because each VSAN uses explicit frame tagging, they can be expanded or extended over metropolitan area networks or our wide area networks. Now remember, each VSAN has its own principal switch and domain ID allocation policy, either static or dynamic. And principal switches for different VSANs don't need to reside on the same physical switch. Each switch has a separate domain ID for each active VSAN. Each VSAN can also have a separate fiber channel ID allocation policy, either static or dynamic. With our devices, initially, as you probably know, all ports are going to be originally configured in the default VSAN 1. Now, it would be really remiss of me in this troubleshooting VSAN section if I were not to provide some really big-time recommended best practices for your virtual SANs. Number one, you know the default VSAN we just talked about, VSAN 1? Yeah, don't use it for your production network traffic. So in our best practice 2, we're going to create a VSAN in order to carry our particular network traffic. My third best practice recommendation is to isolate devices in VSANs whenever practical. Isolation by department and by application are two very common practices. You should also isolate test environments from your production environments. Finally, my fourth recommendation is to continue to use zones, but do so inside each virtual storage area network. Now, we do get a robust set of show commands I'll demonstrate here for you for troubleshooting. We want to be able to verify domain parameters, physical connectivity, verify that both devices are in the name server, verify that end devices are in the same virtual storage area network, and you need to be able to verify that end devices are in the same zone. So what's our bread and butter command, if you will, when it comes to checking VSANs on our device? How about this for straightforward? Show VSAN. You can see the VSANs that are on this device. hey, there's VSAN 1, that default VSAN that we spoke of. Then we can see VSAN 4079. This is the Exchange Virtual Fabric Protocol isolated VSAN. It's used on trunking fabric port to trunking node ports. That's TF-TN port links to carry the Exchange Virtual Fabric Protocol. Notice there is an isolated VSAN, that's VSAN 4094. All non-trunking ports are transferred to this VSAN when the VSAN to which they belong is deleted. Keep in mind, all ports in the deleted VSAN are indeed isolated and disabled. Notice with my VSAN that I created, VSAN 27, we can see that our VSAN name officially is VSAN 0027. We can see the state is active. We can see the operational state is indeed up. So things are looking very good for this particular VSAN. Notice interoperability mode for interacting with other vendors' equipment. We have a no, a yes setting, or the default setting here. The load balancing scheme is also provided under your show VSAN command. But just like our VLANs, so much of our verification process is going to lie with not necessarily the VSAN itself, but its membership. And Cisco thought of this for us. We can say show VSAN, in my case 27, membership. And I can verify those fiber channel interfaces participating in this particular VSAN. Now, what about the situation where we are trunking our virtual storage area network? Well, use the show interface trunk command in order to determine which switch has VSAN allowed list configuration errors potentially. Remember, we use the switch port trunk allowed command in order to add VSANs to the allowed list on each of our trunks. Maybe we have a situation where our Nexus 5500 trunk port does not connect to an upstream SAN switch. Possible causes often include no common VSANs configured on each of the switches, or trunk allowed VSAN members that don't contain common members. So we want to determine the connected ports and resolve the allowed VSANs on the trunk for both fiber channel interfaces of our pair. So a key troubleshooting skill for the data center these days, troubleshooting our VSANs. By no means is this difficult, but it certainly is a critical step in ensuring end-to-end connectivity within an MDS-based or Nexus-based data center. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.